Hi everyone, this is practice formative of chapter 4, question number 22. So in this question, we need to find the number of different arrangements using all the letters in the word commitment, and hence determine the number of arrangements which fulfill the conditions set in ABC. So let's find the first part, the number of different arrangements using all the letters in the word commitment. So over here we see identical items. So let's put down how many M do we have? We have M, 1, 2, 3, 3 letters of M. And then for T, we have 2 T's. Okay, and the remaining will be the individual. So we have individual, the rest will be the individual consonant or vowel. So we have C, O, I, E, N. So we have 5 other letters. So for others, we have 5. So all in all, we have 10 letters here. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, set. So we need to find a different arrangement using this. Therefore, for the arrangement, that will be 10 factorial. And because we have the identical item of M, so we have to divide by 3 factorial. And T, so we have to divide the whole thing by 2 factorial. Let's get the answer from the calculator. Okay, 10 factorial divided by the product of 3 factorial and 2 factorial. Okay, so we have the answer 302,400. Okay. 302,400 ways to arrange the commitment. Now, next we have to find the number of arrangement which begin and end with the letter T. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I prefer to use the fill in the slot method. So the front and the back, we must fill in with T first. So 2 factorial, 1 factorial. Not forgetting, we have to divide everything by 2 factorial because we have identical items. And therefore, the rest will just arrange without any other condition set. So we will then have left with 8 letters. So we will have 8 factorial in between. So 8, because after we fill in 1, so 8 choices, then 7, 6, 5, 4, 3, 2, 1. And not forgetting to divide by the identical M, 3. So 3 factorial. So with that, that will be 2 factorial, 8 factorial divided by 2 factorial and 3 factorial. Simplify this. Okay, the remaining part, we use the calculator to get the answer. So we have 8 factorial divided by 3 factorial. 6,720 ways. 6,720 ways. That's for A. Okay, next part B, the number arrangement which contain triple M. So we must see the M that is together. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whereby we bundle this 3 space just for the M. Okay, so externally we have 8 items. 1, 2, 3, 4, 5, 6, 7 plus a group of M. So we have 8 items. So externally 8 factorial, and then internally that will be 3 factorial. And not forgetting, we have to divide by the identical M and identical T. That will be 3 factorial and 2 factorial. And simplify this. And we just take 8 factorial divided by 2 factorial. So 8 factorial divided by 2 factorial So we have 20,160 ways. 20,160 ways. Okay, let us move on to part C. So part C, we do not want TT to be together. Since T, we only have 2 items, therefore we can use the complement way, which means we take the total arrangement minus the arrangement whereby T is together. Okay, only when there are 2 items. When you have more than 2, we can't use the complement way, but this one we can use. So let's find the number of arrangement when TT is together. Number of arrangements that contain TT. Okay, so use fill in the slot method 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whereby these 2 we group together. So instead of 10 items to be arranged, now externally we have 9 to arrange, and internally we have the 2T to arrange among themselves. So 2 factorial. However, since M and T they're considered identical, they're not distinctive from each other. Therefore, we have to divide by 2 factorial, the double T, and 3 factorial for the double M. Okay, therefore, we shall take 9 factorial divided by 3 factorial. Okay, 9 factorial, so overwrite is the retype it. Okay, divide by 3 factorial. We have the number arrangement 60,480. 60,480. That is the number of ways that contain TT, but we want the complement. So the number of arrangement without TT. Therefore, the overall arrangement 302,400 ways minus 60,480 ways. Okay, so let's minus this. Okay, 302,400 minus the last answer. So the total ways to get the arrangement that do not contain TT will be 241,920. 241,920 ways. 920 ways. So we found the answer. That's it for question number 22.